This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day wherever you're listening from, and welcome. It's episode 482 of IAQ Radio on Friday, October 20th, 2017. This week we welcome Henri Fennell. He's a spray foam expert from up in the Boston area now, but he was in Pittsburgh for a while, and we got to talked to him a while back at summer camp and was really very interested in having him come on and talk a little bit about spray foam. So we're going to talk about building science, indoor air quality, and spray foam issues. Before we do, let's thank our marquee sponsors.
IAQ Radio marquee sponsors are John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net. Particles Plus, engineers and manufacturers, feature rich particle counters, air quality monitoring, instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us. It's the 2017 Healthy Building Summit, November 2nd through the 4th at Seven Springs Mountain Resort in the gorgeous Laurel Highlands of southwestern Pennsylvania. Join industry leaders and educators as they discuss research to practice, navigating changing industries. It's 2.5 days of IAQ, remediation, building science, and home performance. Marquee sponsors include John Don Products, where restoration and abatement contractors shop. Particles Plus, count on us. HaywardsCore.com. Exhibitors are AEML Microbiology Laboratories, TrueTech Tools, Prism Analytical Technologies, FiberLock Technologies, and Instascope by Detection Tech. Register now at healthybuildingssummit.com or call 814-754-4808.
And get those registrations in because we've got limited space, and we've had a really nice response this year. So looking forward to seeing a lot of listeners at the conference coming up November 2nd through the 4th. All right, let's turn it over to the Z-Man for today's IAQ Radio trivia question.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick@cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man with this week's IAQ Radio Trivia question.
Hello, everyone. I'm sorry to report there was no correct answer to our previous trivia question. Carol and Hazel were the names of the first two Atlantic hurricanes to be retired. The IQ Radio trivia question for today, Friday, October 20, 2017, has been sponsored by Ideas, the solution chemistry company creating unique solutions to odor removal, surface cleaning, and decontamination problems. Here's today's trivia question. Polyurethane spray foam insulation was developed and used by the military in the 1940s. Name the type of military equipment to which this foam insulation was first applied. Back to you, Joe.
Thank you, Cliff. Today's guest is Henri Fennell. He is a building envelope specialist and architect with over 40 years of experience in energy conservation, design, products, and services. He began his work with polyurethane foam materials back in and energy-efficient demonstration projects during the energy crisis in the 1970s, including the Pittsburgh Children's Museum. His first spray foam project was in 1971. His work experience has included positions as a practicing architect, a building envelope contractor, and building envelope remediation and commissioning consultant. He's done thousands of remediation projects, he's sprayed million tons of spray foam around the area, and he's been an author. He's working on a couple of ASTM committees, so he's a well-rounded spray foam guy, and we look forward to a great discussion. Henri, do we have you on the phone?
I'm here, Joe. Thanks.
Thanks for having us. Thanks for joining us. I mean, I know you're driving back from a spray foam project in Charleston. Let's talk a little bit about the background, though, on spray foam. I mean, we want to set the table. What are the main components of spray foam? How is it made?
Well, spray foam is a two-component product, and it's generally referred to as A and B. The A component is an isocyanate, and in the polyurethane insulation industry, MDI is the only isocyanate that they use. The B side is where the catalysts and the fire retardants and the blowing agents and things that make the isocyanate into foam. That's where they live inside the polyol, which is the other 50% of the system.
And then let's talk just for a moment about the difference between open cell and closed cell foam. Can you describe for listeners what the differences are, and maybe we'll talk a little bit about when they're appropriate?
Okay. Well, open cell foam is a lower density, generally around 0.5 pound a cubic foot. It's got about a 3.5 to 4.5 bar value per inch. It's an air barrier above a certain thickness, and it's obviously insulation, but it's not a vapor retarder within any practical thickness. Closed cell foams are higher density. They're generally in the 1.75 to 2.5 density range, and they are both vapor retarders above a certain thickness, and the thickness varies with temperature and substrate. But generally, open cell foam, closed cell foams are a vapor retarder in thicknesses we use for insulation. They have about a 6.5 R value, and that varies with manufacturer and product. And they are an air barrier basically at any thickness.
What was the perm rating on that again?
Well, the polyurethane gets to be a perm of less than 1 at different thicknesses depending on the density. So if you spray polyurethane foam and you get a 2-pound density, you need about 2.5 inches to get a perm of less than 1. But if you spray a thin coating on a cold substrate, like something that absorbs heat quickly, like brick or concrete block, you can get a perm of less than 1 in as little as 3/4 inch.
You know, you mentioned spraying on things like brick, concrete block, and stone. How well does it adhere to those types of substrates? You know, let's talk about the closed cell.
Well, the bonding is generally about the same for both products. Polyurethane will stick to most things that aren't release agents, and it won't stick to water or snow, of course. It won't stick to things that have oil on them, like a galvanized metal stud or a galvanized deck. Wax would be a release agent. Polyethylene, it sticks to polyethylene, but it peels a layer of the polyethylene off the sheet, so effectively it seems not to stick to polyethylene, but it really just delaminates the product. So there are schedules of what materials are compatible with spray foam online, and I can't show them to you in this format, but they're readily available online.
Okay, let's talk a little bit about environmental conditions, and when we're doing a foam job, what type of environmental conditions, so temperature, etc., humidity, would be, I guess, ideal for spraying foam, and when would we have environmental conditions that might lead to a bad job? Well,
polyurethane should be installed from the installation side of the equation, it should be installed between probably 50 and 100 degrees. Some manufacturers have cold weather versions of their formulations that you can go down to as low as 20. But when you get really hot, you push the blowing agent and make the foam go to a lower density. So you can use an installation strategy to deal with that, or you can use a chemical strategy. Generally, cold weather formulations have less catalyst because they don't need as much to reach the target density.
What other
temperature is the big one?
Okay, and what other factors or techniques differentiate between a good job and a bad job? So what other things do we have to watch out for with respect to the installation of these? I guess, and also we should probably talk about the fact that you're manufacturing this in the field.
Right. When you take the A and B component and you combine them with a piece of equipment, that's the processing side, and effectively you are manufacturing the foam out of those two raw materials on site. There's industry standard equipment that combines those chemicals, and as long as the chemicals are at the right temperature, and then they do hold at a near 1-to-1 ratio when you process the material. The temperature of the chemicals is key, and the ratio A to B is key. Those are the processing side. On the installation side, you have formulations that have limitations on pass thickness, and a pass is how much you lay down in each layer as you build up the foam. And most closed cell systems are in the 1.5 to 2 range. There's some new products coming online that have higher pass thickness limits. And the open cell foams probably are running, you can spray up to 8 inches in one pass with most systems.
Why the difference?
The answer is heat. If you spray, when you spray the foam, there's an exothermic reaction when the two chemicals are combined, and that creates heat, and that heat boils the blowing agent, and that's what makes the tiny bubbles in the wine.
Okay.
The open cell foam has a different blowing agent, and it doesn't get as hot when you process it and spray it, and those chemicals don't get hot enough to decompose due to heat. In the closed cell foam, the heat of the reaction is high. It might be as high as 300 degrees, and of course it's inside the insulation, so you spray a limited thickness to keep the heat at a reasonable level, and then you wait between passes. That's called the dwell time, before you put the next layer on, so the first pass can cool, and then you add more over top of that.
How long of a dwell time should there be?
Well, every manufacturer provides that information in his publications, or they should. But generally, it's between 10 minutes and a half an hour. I've seen higher numbers than that, but part of that, again, Joe, you know, if you're spraying it on a 30-degree day in New England, that's going to cool down quicker than if you spray it on a 100-degree day in Charleston. So it depends on the environment to some extent, and if you really want to know, the target is you want to get the core of the material down to 140 or less before you put the next pass on. Most manufacturers publish time limits instead because they, you know, not everybody's going to take time to measure the core temperature.
Well, that's one issue. There's another one with the ratio I want to talk about a little more. But before we do, my understanding is this exothermic reaction can get hot enough where we can catch the place on fire. How often does that happen?
I've only ever heard of one fire in a building in my career. You can easily start a garbage can if you just fill it with spray foam. A big blob of foam that big it'd be very hot in the core, and you could actually start a fire. But it's pretty hard to actually start a fire with too thick a path. But it does damage the core of the material where the temperature gets above the design temperature, and then those cells in the middle are charred. They call it charred or burnout, and then they don't perform. So if you're looking for good performance as well as avoiding, the potential for a fire, you stay within the pass thickness and wait between passes the proper time.
I want to get one more in here, and then Cliff, I want to turn it over to you and see if you had anything you wanted to follow up on or any questions. But you mentioned the 1-to-1 ratio, and I know when you and I talked, you've actually, developed a mechanism for making sure that people have that 1-to-1 ratio. Do most contractors just rely on the equipment to provide that 1-to-1 ratio?
Well, the general answer is yes. The equipment is reliable in that the machine that takes the chemicals and pushes them to the gun in a 1-to-1 ratio. That's what's called a positive displacement pump. The problem can happen in the field where either the chemicals aren't warm enough or there's a restriction in the transfer system from the chemical storage containers to the pump, or there can be a restriction on the other end at the gun end if there's a partial clog or restriction. So you can process 1-to-1 from the pump capability perspective, but you can starve the pump, or you can restrict the flow on the other end.
And what kind of issues does that cause when you don't have that 1-to-1 ratio?
Well, if you're off ratio, you really want 1-to-1, because at that condition, all of the chemicals react with each other, and they're all used up in the reaction. If you go too far off ratio, then you have chemicals that never see the other side, and they don't react, and then you have raw unreacted chemicals on the substrate or in the foam itself.
And I wonder if you could maybe describe, I know it might be tough, you've developed a way of monitoring that, I guess, as contractors do this work. Can you kind of describe what you developed?
Well, people who manufacture foam in factories, they have specialized equipment that checks the flow rates of the chemicals and the temperatures and so forth, because they want to make good product all the time, and they're in controlled environments, and that's easy to do. When we go out in the field in buildings, you may have buildings in the winter that are 20 degrees, and you may have buildings in the summer that are 100. The roof might be 160. So we don't have controlled environment in the construction industry, and we also don't have the kinds of automatic monitoring systems that will tell us when things aren't right and shut the equipment down. So what you're left with, if you don't buy that sort of aftermarket monitoring system with fault protection capabilities, you can at least calibrate your equipment periodically and make sure that it's running on ratio. And that's what I've done. Is it's not a brand new technique, but it's something that most people are not doing, and I'm trying to get the industry to adopt that method as standard practice.
So how often would they calibrate then?
I don't know. How often do you want to make sure you're on ratio?
Yeah, exactly.
I think what I do when I commission a project where I'm, monitoring an installer's work, I check the ratio every day, because in the morning when the chemicals haven't been heated yet in the hoses, you can calibrate the pump. But a full-time monitoring system, you would be looking at it all day long, every day. But when I train installers to calibrate their equipment, they generally do it on a once-a-week basis. And, there's other values to calibrating the equipment besides knowing that you're on ratio and being able to market that to your clientele. You also see trends for how your equipment works, and if you see you're headed off of your normal track in terms of ratio, you can start looking for a problem to troubleshoot.
I just think that's something that a lot of our guests would relate to, because a lot of our listeners would relate to. They're, a lot of them are indoor air quality professionals, and they're always calibrating pumps and making sure their measurements are accurate. And I find it interesting that doesn't happen as often as maybe we would hope out there manufacturing foam in the field. Cliff, let me turn it over to you, see if you have a question.
Well, I've got a couple. Actually, the first one that comes to mind is, the chemicals are pumped through hoses and through nozzles. How do they clean that stuff out at the end of the day, or, if they have a clog, or, how is it flushed out or cleansed?
Well, the chemicals, as long as they're not mixed, are, they're fine in the hoses and in the equipment, as long as they're kept separate, because they don't turn to foam. So by the same token that you can have two drums full of A and B, you can have two hoses, one with A and one with B, and they don't have to be cleaned out, as you put it. They just stay in there and stay under pressure.
Okay.
The two chemicals come together at the nozzle of the gun within about 1/8 of an inch of the outlet of the gun. So those two chemicals are pinged. In other words, they have a head-on collision in the chamber, and then they go right out of the gun. So there's really nothing to clean out except possibly that chamber, and the guns have air flowing through them all the time, and it pushes most of the liquid out, so it's not a big maintenance item.
Okay. I guess my second question is, if some sort of error was made in terms of the ratio or the temperature being off or whatever, and we have a problem installation, can you put good material over top of bad material as a mitigation or correction strategy, or does all the bad material need to be physically removed?
Well, as usual, the answer is it depends. If the material, it depends on how far off ratio the material is, and it also depends on what the unreacted chemical is. Isocyanate will react with water, so in a fairly short period of time, it will crystallize and become benign. Let's say, it's not going to outgas anything. It's not going to react with anything. But the right protocol, if you process material that isn't fully reacted, you want to clean up the unreacted chemical and then spray good material. But you shouldn't spray good material over unreacted chemicals. The other thing is, if the foam is slightly off ratio, and there's a range for this depending on the product, but if it's slightly off ratio, it may have dimensional stability issues that might cause cracking, but it doesn't mean the foam isn't good or isn't a good insulation material or an air barrier, other than where the cracks are, of course. So there are repair strategies for close to on ratio products that work. The first test is it a health issue? If it's not, then you can try to repair it.
Let's talk about some of the other types of problems. What are the most common problems you see with foam jobs?
The majority of the foam jobs, maybe 80%, are ratio issues, and after that, it's the next contender is spraying too thick a pass. That can be an issue.
And what happens when when you have a problem like that? How do you tell? I mean, how can you look? Can you look at it? Does it smell different?
If you spray too thick a pass, if you cut a sample out of the foam and look at the cross section, you can see what I call the frontiers between the passes, and that's where the skin of the material forms on top of any pass in a spray foam application. So if you see that if the manufacturer says 1.5 to 2 inches and you see a 4-inch pass, then you know that that's a potential issue. The real key to determining when that's a problem is if you do a density test on the material near the surface and then the material in the center at the core, you will always see a higher density at the skin on both the substrate side and the exposed air side. In the middle, if the core density gets below a certain level, and that varies with product, but generally it's below 1.65 in density for a 2-pound system, you won't have good dimensional stability. And you can take samples and put them in a hot box or in a freezer and check to see if they're going to shrink or swell or crack in a test outside of the actual building.
Could you describe for listeners how you do that? The test for the depth of the foam. I mean, is it you put an ice pick in there? Is there a specialized tool for it?
Well, an ice pick will work. I use a big knife with the inches marked on it and check the thickness that way. But the guy who's spraying uses a tool. Might be a bent piece of wire or whatever that has a kink in it at the design depth. So if he's supposed to spray 5 inches, he pulls it out of his pocket and pokes the foam. And if it's, if he needs another 1/2 inch, he puts it on. And if it's, at or above the required thickness, then he moves on to the next area. So yeah, it's pretty straightforward. You just want to measure from the substrate up to the top of the foam. Now the confounder to that could be if there's a space behind the foam, an airspace, and if you spray 3 inches of foam and there's a 1-inch airspace behind it, it'll measure 4 inches, and it's only 3. So that's where taking a core sample out of the foam and measuring the core sample is more accurate.
And how big of a core sample do you take? Is it 1 inch by 1 inch, 3 by 3? And when you're done, how do you repair that?
Well, I have a 3-inch core drill, and that's based on some old sort of industry standard equipment. But you can take a knife and just plunge cut a square and flex it so that the bond with the substrate breaks, and then you can pull it out. You can look at it and measure it and put it back, or I carry a 1-component can type of foam, and I can actually foam the hole back in.
Gotcha. Okay, that makes sense.
Depends on the client. I mean, if you're going to take it all out, you don't bother. But if you're going to repair it, or if it's fine, then you put it back and seal it in place.
All right, Henri, we've got to stop and thank our sponsors. Listeners, we'll be back in 90 seconds with Henri Fennell. Interesting stuff, this whole foam industry. Very interesting. We'll talk a little more in the second half about issues that come up on jobs and how we evaluate them, and a little more about the indoor air quality side of things. We'll be right back.
IAQ Radio would like to thank our association sponsors. The Indoor Air Quality Association, a nonprofit multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Visit them at IAQA.org. Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them, wolfsense.com. IAQ marquee sponsors are John Don Products, where restoration and abatement contractors shop. Visit them at johndon.com. That's JONDON.com. Healthy Indoor Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions are available at IAQ.net. Particles Plus, engineers and manufacturers, feature rich particle counters, air quality monitoring, instrumentation, and vacuum pump technology. ParticlesPlus.com. Count on us.
Okay, we're back for the second half of our interview. We've got Henri Fennell. And Henri, I'm wondering, how common are problems with spray foam jobs? I mean, is there actually been a study done to determine, 1 out of 10, 1%, 3%? What do you think?
Well, I don't know where the data comes from, but I understand that less than 1% of the installations have problems that we know about.
Okay, but there are enough of them where people like you, and I know one of our regular listeners has been on, John Lapotere. He goes around and does a lot of foam work. How often when you get called on a job like this, do you find there is an issue, or are there times when you get called and you find that, it's just fine, and maybe it's a misperception by a customer?
Yeah, that's a good question, Joe. Sometimes people read stuff online about foam problems and then suddenly they have a problem. But most of the calls I get are legitimate calls with people who, it may be a localized problem, just one spot where they saw some unreacted chemicals. It's possible that the installer, one of his drums ran empty and he didn't change them over quick enough, and he gets one little area that's off ratio. But it's I don't get very many calls that aren't valid calls, but I'm not doing thousands or hundreds of these a year. I'm doing tens of 100 or around 100 a year. And I go all over the country, so, it's not very frequent. It's unfortunate when it happens.
When it does happen, it can be a real nightmare for people, as I understand it. What about mold growth? Can foam support mold growth?
Well, you can have mold growing on the surface of foam, either open cell or closed cell. But I've sampled foams that have mold on the surface. I've never seen any sign of it inside the foam. So I think what's happening is you have a moist environment with dust and spores in the air, and it forms on the surface. It's like any other surface in a crawl space or attic or wherever. But it's not supporting it as a food source.
Okay, what about odors? What does a bad foam job smell like?
It's hard to talk about.
It is. We've got to paint a picture on the radio here.
Yeah, right.
It's not even a picture, huh? It's kind of paint an odor. I don't know how we do that.
Yeah, it depends on the chemical formulation and what in the formulation that has an odor when it isn't fully reacted. That's when you get the odors, is if you have off-ratio material. And it can be, because you have 5 different components in the B side of the product, you don't know which of those it is. And when you look at the SDS sheet for the formulation, some of the compounds will be identified as trade secret or proprietary.
Mm-hmm.
So, you have to send the samples to the lab of the foam to find out if they're providing an odor. But first of all, the A side doesn't have an odor, and of course it's water reactive, so it's quickly fully reacted, and isocyanates are a problem for the installer because he's in the environment where it's unreacted in the air. But they're generally not a problem for owners or consumers. The B side, it could be a surfactant or a catalyst. Amines catalysts are an odor that you might be able to identify. Some people call it a fishy smell. Some people call it like a urine smell.
Mm-hmm.
But generally, if you can, if the odor started right after the foam job was installed, that's a pretty good clue. But we can send a sample to the lab. They heat it to force the outgassing, and then they analyze the headspace product to determine what's in the air or what the outgassing is.
And what does a bad foam job look like? I mean, is a lumpy foam installation necessarily a bad installation?
That's a good question too. A good installer with good technique won't make a let's call it a lumpy installation. It'll be more smooth, more like more regular. Let's just put it that way. But you can spray good quality foam material with bad technique and have it be 3 inches in one area and 6 inches in another area, and where a good installer can generally be within plus or minus a half an inch, or I used to guarantee plus a half minus a quarter when I was an installer. So you can get pretty accurate. And, bad looking foam in terms of just the aesthetic appearance will still perform as long as it's continuous. If you have a bare spot with no foam, of course you could have an air leak or a condensation issue in that local area. But if you have foam that varies in depth and you do a heat loss calculation on 50% of the area 3 inches thick and 50% of the area 4 inches thick, you're going to have the same heat load as if you had a 3.5 inch thick uniform thickness.
And what about color or discoloration? I sent you some photos not long ago. I think it was kind of unusual. This job had little brown dots on it, basically almost looked like little puddles of muddy water or something like that. They were real small. I understand from what you said that's not real common, but what else would we look at? I mean, what color should it be? Should it be a consistent color?
Well, the answer is it should be a uniform color on the surface and inside the foam. So if you had foam that was going from almost white to almost brown, that's a change in ratio. What happened in the job you're talking about, they ran out of the B side chemical, and for a second their gun was just spurting A side alone, and that was spatter from that event. That they recognize that immediately, and they stop spraying and they go put new drums on the pump and get back to work. But generally, the surface should be uniform in color, and a cross section through the foam in parallel to the surface or perpendicular should be the same. The cells should be relatively small, meaning less than a 1/16 of an inch, and uniform throughout the cross section. Once in a while, you might see what's called a blowhole, which is just a big cell where some of the blowing agent made a bigger was concentrated in one spot and made a bigger cell size. But generally, they'll all be really small, uniform, tight. If you see elongated cells perpendicular to the rise, that means that they didn't wait long enough between passes, and the foam was produced on a hot surface that was too hot. Should have been more dwell time between passes to cool down. You can learn to understand what different cell configurations mean, but generally you're looking for round, uniformly sized, consistent color throughout the product and on the surface as well.
So the surface
if you see
and below should be a consistent color.
Color and cell on the surface you won't see cells, but uniform color on the surface, and the colors vary. Some products put dyes in their product to give it a trademark, but they should be the same color on the surface and the same color and consistency throughout the cells if you cut it open.
Very good. That's a great tip for listeners, I think. Cliff, before I move on, is there anything you wanted to jump in here with?
Well, at some point, are you going to cover remediation?
Absolutely.
How they do it?
Absolutely.
Okay.
I got one more question I'd like to get to on the installation, etc. And it's really not so much a question as it is a comment that I'd like you to add to, Henri, because when we talked before the show, I got the impression probably the biggest mistake installers make is not making sure that people are out of the home when they do this or out of the building when they do this work, and secondly, not ventilating the area properly when they're done. Would you agree?
I agree.
And
as you know. Go ahead.
Well, now I was going to say that, when we're talking about ventilation, I think sometimes people, that aren't taught this don't realize what ventilation is. A lot of times when you're doing a spray foam job, as you mentioned in the beginning, it helps with your vapor barrier, it helps with your air barrier, and it's basically, it's a thermal barrier, but it's also sealing that room up. So ventilating the room is more than just throwing a fan in the window.
Well, throwing a fan in the window, if it's a big enough fan for the size of the space, that can help. But as the room gets tighter and tighter, you need a way for fresh air to get into the room so that you're not just running a fan that's stalled against, a dead end. So the proper protocol for ventilating a space that's being foamed is to have equal inlet fan pressure and outlet fan pressure. So you want to balance the flow, so you provide fresh air at the point furthest away from the point where you blow the air out. And you want to make sure you don't blow the air out, at a sidewalk or a place where people might be, because that's an obvious air quality problem.
A playground or something like that.
Sidewalk, whatever. But balanced airflow is the key, and most installers only depressurize the space. They just blow out the window, as you put it. And that can lead to other problems. You can have combustion appliance backdrafting if you depressurize the house. Let's say you're only doing the attic and the rest of the house, the heating system is on. In the winter, you can backdraft a fired appliance in the basement or another part of the building. So you want to either use an alternate source or make sure your makeup air for that combustion appliance is adequate.
And how long do we typically need to ventilate after one of these jobs? I guess a two-part question. How long should the people be out of the home or the building? Secondly, how long should we ventilate?
Well, the answer to them is the same generally. The people need to be out of the building so they don't get sensitized to the components in the foam. The installers should be wearing personal protection equipment so that they're not at risk. But if there's people in the house, even if it's another part of the house, if the central heating system or air conditioning system is circulating that air, that can be an issue. But you want people out of the house while they're doing the work, and then for as long as the manufacturer says the cure period is. And that should generally be between 24 and 72 hours. But, some people don't want to have to be out of their house for 2 or 3 days, so they're pushing the envelope when they're trying to get in. And some manufacturers talk about much shorter cure times or reoccupancy times, as it's called, because they're afraid people won't want to have the foam installed if it means they have to move out of the house for a couple of days. But the key is, whenever they use a short reoccupancy time in their literature, they always caveat that with add a certain level of ventilation. And the ventilation is there to make sure that the vapors and so forth are removed from the environment. Removing the vapors from the environment is the right thing to do, but that relies on the installer to use the right kind of ventilation. And as we talked about, that's not always going to be a balanced. They may be blowing air out from a dead-end attic because they just made it all hermetically sealed, and there's no way for fresh air to get in there, so they're not really doing anything, and then that space still has vapors in it after a shorter reoccupancy time.
Yes. Now, quickly, I've got a comment from a listener. Another issue could be not cleaning the hoses between jobs and then switching products, say, from an open to a closed foam. Would you agree that can be an issue?
Yeah, it can be an issue because both chemicals won't get to the gun at precisely the same time. So for a while you have a hybrid material that's neither one or the other. Okay. It's also possible when you switch from one component to another to have the transfer system from one product may have air in it because it wasn't, the last time they used it, they ran out of that chemical. And then you get essentially a short period of time where there's nothing coming up the hose on one side but air compared to the chemical on the other. So you can go off ratio for a very short time, but it's, it can be a limited area problem.
Let me get you to comment on one more investigation type question, and then I want to spend the rest of the time talking about remediation like Cliff suggested. Are there any agreed upon protocols for air sampling to confirm if foam is off-gassing more than should be expected? So we have IEPs that listen to the show. Are there any agreed upon protocols for going in when someone's complaining about this issue and then taking air samples, for instance?
Well, only the labs can diagnose, the outgassing. I've been looking for equipment to use on site, and I have not been successful with that so far. But taking either air samples on site with standard protocols or take a physical sample is also an option, sending them to the lab.
But as I understand it, there's not a consistent protocol. I mean, different labs look at it different ways. Has that been your?
Well, there are multiple tests, and I think that the tendency for labs to say that the tests are possible or not has more to do with what equipment they have and what their capabilities are.
Interesting. Well, let's go to the remediation side of things here. So we've got a bad job, or we feel that for whatever reason the foam is creating some kind of a problem. What are the options for the building owner at that point?
I'm sorry. You mean if the problem is not?
Well, let's
explain a little more.
Let's say we've got an odor issue. What are my options as a building owner? Do I have to remove that foam? Can I cover it up? Can I ventilate a little better? What type of remediation options do you give people when you go out on these projects?
Well, there's a short list of options. One is to neutralize the chemical that's not fully reacted, and that requires the manufacturer to tell you what will neutralize that component of their product. You can clean, and that again requires knowledge of what the chemical is that is unreacted. And that may be the cleaners that would be required to remove that might be worse than the original problem, or in some cases, like an amine catalyst, you might use vinegar as a neutralizer or a cleaner, and that can be an odor issue, but it's short term relative to the life of the foam. Another one is encapsulation or isolation. That means you put a barrier between the material and the living space, and then depressurize that space behind the barrier. So it's like a radon system, but for, let's say you have an attic, you can maintain a negative pressure in the attic that's always a higher negative than the house can be. Another one would be a foil scrim type of membrane that would be between the living space. You can encapsulate with coatings or with membranes. It just depends on how convenient it is to install that and maintain a pressure behind it that guarantees minimal outgassing.
And what about
then the next step is repair. Sorry.
No, please go ahead.
Okay. The next step is repair, and that's for situations when the foam is not so bad that it can't be used as insulation, and it's not an odor issue. And then you have to stabilize the foam that's there so it won't crack. If the characteristic is cracking, not odoring but cracking, then you stabilize the foam by completing the cracking process by slitting the foam in a pattern that guarantees it won't slit again. You relieve all the pressures, all the stresses in the foam, and then you skim coat over the whole thing with foam that fills in all the cracks. And then the final one is removal and replacement.
And when you do removal, you can get a lot of it, but you're obviously going to have a hard time getting it all. Once they get the bulk off, are there any products or techniques you recommend for getting the little bit of residue that's still stuck to whatever substrate?
Well, that's a tough one. And, I have done projects where they removed all the foam and the odor was still there. And then you go back to the same set of possibilities. You can, sometimes dry ice sandblasting will, or not sandblasting, but dry ice blasting will get enough material out of the surface of the wood substrate to eliminate the odor. Sometimes you can neutralize or clean the surface, and then encapsulation is the final option. Using a closed cell foam over an area that has had an odor issue is often a possibility that reduces the rate of release, is what I call it, and lets you ventilate at a very low level, so it's not a big energy penalty, and you maintain that safe boundary by depressurization.
I see. Cliff, did that answer all of your questions, or do you have a follow-up?
It did. I was just wondering, other than vinegar for an amine odor, are there any other types of chemicals or brands, whether it's generic or proprietary, that might be useful?
Well, I think in every case, if you can, the ideal situation is to send a sample of the material to the manufacturer. They don't have, they don't have proprietary or trade secret issues to worry about. Their labs know what's in their product. So I like to send a sample to the manufacturer and have them tell me what's the best way to remediate, the odor.
Right.
Some manufacturers will help with that, and some won't. And when you get to manufacturers that won't, you have to deal with solutions that work for families of chemicals instead of specific chemicals.
I'm wondering, Henri, do you, you work with spray foam a lot. You've been doing this for many, many years, and some people say that, they now have a sensitivity to spray foam and that they can't be around it at all. And, others may poo-poo that and say, well, come on, you're kind of overplaying this. What's your experience with that? Do you feel some people do become sensitized to the point where they can't go back into that home?
I think the answer is yes. It's not. It requires a combination of two things. One is someone who's already has respiratory issues and is sensitive to certain chemical compounds, but the installers need to evacuate and ventilate to prevent sensitization from happening to people who generally wouldn't otherwise become intolerant of the chemistry.
Now, when you were applying this product, you applied a lot of it over the years. I'm just wondering, with your own employees, did you ever have anybody that ended up with the sensitization?
Well, of course, the installers are sensitive to the isocyanate, and they're exposed to other compounds in the foam for very short times. The only the isocyanate is a short-term problem for an installer, and we use supplied air or VOC cartridge respirators and protected ourselves. So I don't think I ever lost any installers due to sensitization. It would have been for other common reasons.
Sure. We all lose people from time to time. Cliff, before we wrap this up, did you have any final questions?
I'm good, Joe. Thank you.
Let me just ask one more real quick one here, Henri. It may not be as quick as I would like, but, we can go over a little bit here. I want to know if you could give consumers and a lot of our IEPs and our restoration people, they're all consumers as well. What are the most important tips you would give them with respect to, they're going to have a foam job done in their home? What are the things that are most important for them to do to ensure that it was done right?
Well, you want to use an established product that's been used on for lots of other buildings. You don't want to be the first one in on a new formulation. And then the same with the installer. You want to use an experienced installer who understands, has been around long enough to know what the problems can be. And then, the most of the foam manufacturers have websites with sections in them on what the consumer should know or be aware of when they hire an installer or use foam. And the other thing is a homeowner should ask for a written safety plan in advance of the work so they're fully informed about what the risks and so forth are, and so they know what to do with evacuation and ventilation. And if the installer does not have a written safety plan, I'd look for another installer because it's required by law.
Good points. And before we go, Henri, is there anything we missed you'd like to add? Anything you'd like to add at all?
No, I'm being totally reactive, but I'd say it's the best product in the world, and it has it needs to be done properly.
Well done.
It's a great building envelope material. It can solve vapor problems where other products can't. And I'd say just do it right for the installer, and the owner should pre-qualify their technicians.
I got one final text from a listener saying that there's SPFA guidelines for installation, inspection, removal. Would you recommend that people ensure their installer is following those?
There's guidelines for removal.
No,
that's news to me.
No, this is for installation.
There are definitely guidelines for installation.
Oh, okay.
And that's for the installer, not for the homeowner. But if a homeowner wants to understand what the installer should be doing, that'd be a great place to look. Yeah, the SPFA is the Spray Polyurethane Foam Alliance, and they're in the process of always developing standards for new, for the work that's being done, and for best practice. That's what I'm looking for.
And he's saying there is a new guideline on removal, so maybe you guys can look into that. One of the things that I think, and I don't know whether you mentioned this or not, that the manufacturers also have very good information on their websites about what their applicators should be doing.
Correct. That's right. But it would be difficult for a homeowner to police that, I guess is what I want to say.
Gotcha.
Because number one, you'd have to be there while he's doing the work, which is inappropriate. And number two, if you don't know what he's doing, if you haven't done it, you probably won't pick up on the subtleties.
Well, I've gotten a couple great emails already and texts that this was a really good show, and they all expressed their thanks for you joining us. I want to do the same. Henri Fennell, thank you for joining us today. I've learned a lot about spray foam I didn't know. And Cliff, any final thoughts from you?
No, great show.
All right. Well, thank you so much, Henri, for joining us. I know you're driving back from Charleston and stopped along the way, and we really appreciate you taking time out to join us today on IAQ Radio.
Well, thank you, and anytime.
All right. Well, this is Radio Joe Hughes saying thanks again to this week's guest, Henri Fennell. Of course, I want to thank my co-host, the Z-Man, Cliff Zlotnick, at the controls. John, you got to have faith. Most importantly, our growing group of loyal listeners. Next week, we've got a great show. We've got Peter Crosa and Jamie Muzakis from the Harvey Cohen group down in Florida. going to continue our coverage of the hurricanes, and we promised we would stay with that until the recovery was well along the way. So we'll be back next Friday at noon with the next broadcast of IAQ Radio.
For IAQ Radio, I'm Spike Reel saying thanks for listening.